Welcome to the class. Today topic is Bohr model for hydrogen atom. Okay, Bohr model for hydrogen atom. Okay, there are 4 points actually it has, but point wise. First point in Bohr model for hydrogen atom. First point is electron in a hydrogen atom. Okay, Bohr model for hydrogen atom. Bohr model, here what we are studying is Bohr model for hydrogen atom. For which atom we are studying is hydrogen atom. Let us take a look on first point. The electron in the hydrogen atom can move around the nucleus in circular paths of fixed radius and energy. These paths are called orbits. Okay. Electron in a hydrogen atom can move around the nucleus in circular paths of fixed radius and energy. These paths are called orbits. Okay. This is treated as a hydrogen atom. Electron moves around the nucleus in a circular path. This is circular path. Electron in a hydrogen atom can move around the nucleus in circular paths of fixed radius. It has radius. There is a distance between these two is r. Fixed radius and energy. These paths are called orbits. This path, okay, this path is known as circular path. Okay, this path is known as orbit. Electron moves around this. This is nucleus. This is nucleus. This is known as, this circular path is known as orbit. Okay, orbit. Okay. If the number of these circles are increased, we known as orbits. Okay, number of circles increases, then you can call it as orbits. Okay, it has fixed energy. This circular path has radius and energy. Okay, this path has fixed energy. This path has fixed energy. Okay, this path has fixed energy. Okay. Electron in a hydrogen atom can move around the nucleus in the circular paths of fixed radius and energy. These paths are called orbits. This type of paths, okay, this type of paths are called orbits. Okay, here in hydrogen atom, let us take electron configuration for hydrogen 1s1. So one electron is present, it is circulated like this. Okay. There are another orbits also present. Another orbits are also present like this. But electron only presents here only. Okay. 1s1, this is 1. 1s1, electron only circular. This type of paths, this path and this path, these are also called as orbits. Okay. One orbit, second or third orbit. Okay, these are known as orbits. Okay, each orbit has some radius and fixed amount of energy. Okay, this one radius is, let us suppose it has taken as r1. Okay, this radius is r2. Okay, next this one to this one, radius is the distance between this, from this point to this one is known as r3. Okay, circular paths of fixed radius and energy. These paths this one has fixed radius and energy, and this path also has some amount of fixed energy and some amount of radius. Okay, this one has some radius and this one has greater radius, and this one has, this path this orbit has greater radius than compared to this one and this one. So it has greater energy. Okay. this orbit has some energy, this orbit has different energy, this orbit also has the different energy. That is the reason why they mentioned the first point. Okay, the electron in an hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbits. So, number of the circles are increases, this is number of orbits are also increases. That is the reason why they called it as orbits. Okay, next, second point. Let us focus. Second point. The energy of an electron in an orbit does not change with time. Does not change with time. However, the electron will move from lower energy state to higher energy state when required amount of energy is absorbed by the electron. Okay, na? Okay, next point. Energy is emitted when electron moves from higher energy state to lower energy state. What this point says? Second point, the energy of an electron in an orbit does not change with time. Let us take an electron which is revolving around the nucleus. Suppose it is revolving around the nucleus like this. The energy of electron does not change. Okay, whenever the electron revolving around this circular path, this electron energy does not change. Okay, with time. Okay, 3 days or 4 days or 10 days or 10 years or 20 years, the electron energy, whenever electron moves in circular orbit at a particular path, its energy does not change. When the electron energy changes, whenever this electron absorbs energy from the outside, when electron absorbs energy, it can move lower energy state to higher energy state. From this one to this one is possible. Okay, electron energy changes because electron jumps from this one to this level. Okay, this orbit to another orbit, then energy of electron is changes. Okay, why it is changes? Because electron absorbs the energy, then shifts its position from one level to another level. Okay, that is the reason why. Okay, however, the electron will move from lower energy state to higher energy state when required amount of energy is absorbed by the electron. So, required amount of energy, whenever this electron gets required amount of energy, this electron jumps from this level to this level. If the electron gets more energy, then required amount of energy, then electron goes to another level. Okay, if you give a lot of energy, then electron moves to another level. If you given another extra energy, then it will goes to another level or another level. Okay, depend on the how much energy you are supplied to the electron. Okay, you have supplied limited energy, then electron goes to from this level to this level only possible. If you supply more energy, then electron goes to this level to maybe this level. Okay, because you have supplied more energy, then electron goes to another level also possible. Okay, this is the way they are saying. Okay, the energy of an electron in an orbit does not change with time. Okay, whenever you leave the atom, you cannot supply any energy to the atom, then electron moves around the nucleus in circular orbit, but its energy does not change. Energy of electron in the orbit does not change with time. Time passes, the electron will move around the nucleus, but its energy does not changes. Okay, whenever you supply energy to an atom, electron goes to lower level to another level. If you supply more energy, then electron goes to another higher level. So depend on how much energy you are supplied. Okay, you are supplied limited energy, then it goes to one level to another level. You are supplied more energy, then it goes to another higher level. You can understand like that. Okay. Next, energy is emitted when electron moves from higher energy state to lower energy state. It is also possible. Electron in higher energy state is not stable. Okay. Whenever electron goes to from higher level to lower energy level. If you take electron revolving around the nucleus like this, here electron moves in this orbit. Whenever electron moves from higher level to lower level, it can emit the energy, it can give the energy. Okay. It can jumps from this level to this level, it can use the limited energy. Whenever this electron jumps from here to this one, it can use more energy. Okay, the energy orbits are difference is greater, then it can use the more energy to the surroundings. Okay, this is the way you can understand this one. These 2 points. Energy of an electron in an orbit does not change with time. Whenever you live with the atom, the energy of electron does not changes. If you supply the energy to the atom, electron moves to lower energy state to higher energy state. Okay. Electron moves from lower energy state to higher energy state when required amount of energy is absorbed by the electron. Okay, required amount of energy is absorbed by the electron, then only electron goes to lower energy level to higher energy level. Okay, there is another possibility we know. Electron in higher energy state is not stable. So, electron moves from higher energy level to lower energy level, it can emit the energy. Energy is emitted when electron moves from higher energy state to lower energy state. Okay. In this way you can understand it. Next point. This is the next third point. What do you understand from the third point? Frequency of radiation absorbed or emitted when transition occurs between two stationary states that differ in energy by del E. Okay. Let us understand it. Whenever electron goes to from one level to another level, okay, for example, electron in this orbit has energy E1. In this orbit, electron energy E2. Okay, electron, when the frequency of radiation absorbed or emitted when transition occurs between two energy states differ by energy del E. Okay, these two levels has energy difference is del E. Okay, del E means E2 minus E1. Okay, this energy minus this energy means the difference between these energy states. Okay, we know from the previous point, we know each orbit has fixed energy. Okay, first orbit has some fixed energy and the second one has some amount of fixed energy and third one has some amount of fixed energy. Okay, difference of these two energies are indicated like this. Okay, E2 minus E1. We know the formula from the Planck's constant, Planck quantum theory, del E is equal to h nu is equal to del E by h. H is a constant that is known as Planck's constant. Okay, del E means E2 minus E1. E2 minus E1 is energy difference between these two levels. Okay, that is the point which they are mentioned in third point. Next, E1, E2 are energies of the lower and higher allowed energy states. This is lower energy, this one is higher energy of allowed states. Next, fourth point. The angular momentum of an electron in a given stationary state can be expressed as mvr is equal to nh by 2 phi. Okay. Angular momentum of an electron, angular momentum of an electron in a given stationary state, these are means of stationary states, each one is stationary states. Angular momentum of electron in a given stationary states can be expressed as mvr is equal to nh by 2 phi. mvr is equal to nh by 2 phi. Angular momentum is equal to nh by 2 phi. What is the means of this angular momentum? Whenever certain mass moves in a straight line, we call that object has momentum. Momentum is m into v. Mass into velocity. Mass into velocity is known as momentum. It is valid for linear motion. Any linear motion. For linear motion. Linear motion. Object moves in a straight line. Okay. Like this. Object moves from this one to this one, this point to this point, or this point to this point. Like this. In a straight line they go. They move. Certain mass of the object moves in straight line. The object has momentum. The object has momentum, mass into velocity. Okay. Next, whenever this mass containing object move in circular path, it has angular momentum. It has angular momentum, that is known as mvr. It is also countable, radius also countable. Whenever electron moves in circular paths, it has angular momentum, not at all a momentum, because it moves in circular paths. Any body which moves in circular paths, it has momentum and radius. This is known as angular momentum. Angular momentum is known as mvr. Okay, circular motion. Okay, another object moves in straight in linear motion, then it contains momentum only. Okay, whenever this object moves around the circular paths, then only it contains angular momentum. Okay, here there is no angle, so only momentum is only enough. Here there is angle and momentum is known as angular momentum. mvr is equal to nh by 2 phi. What is the means of nh by 2 phi? Means, how can you prove mvr is equal to nh by 2 phi? Angular momentum is equal to nh by 2 phi. Simply in intermediate we will learn mvr is equal to nh by 2 phi. Okay, the detailed explanation how the angular momentum is equal to nh by 2 phi is equal to angular momentum is equal to nh by 2 phi. How it is possible? You can learn in higher classes of quantum mechanics, can prove. Okay, mvr is equal to nh by 2 phi. How it is possible? There is a lengthy problems are present for the proving this concept. The basic ideas they are introduced in intermediate, but the in detailed concept for hydrogen atom or some other things are not here. These are present in higher levels in post graduation, like that. They have given the in details how it is proved mvr is equal to nh by 2 phi, how it is correct. Okay, you cannot bother about this. You simply read mvr is equal to nh by 2 phi. Angular momentum of an electron in a given stationary state can be expressed as mvr is equal to nh by 2 phi. That's enough. Okay, this statement is enough for the intermediate. Okay, you can understand four points. Okay, in Bohr model. Today we discussed 4 points. These are the 4 important points everyone should write in the examination, and in the examination also it is the important question for your annual examination. Okay, next another detailed concept we can explain. Okay, that's it.